Well, hi, Linda. Did you have a good 4th of July?
Yeah, yeah. I just finished my they just installed brand new bookcases in my living room, and I just finished putting all the books in it. I have to. Hi, Jerry.
Hi, Linda.
Ah, where's the There it is. I'm gonna turn my camera around.
Mhm. I decided I was, oh my goodness.
Those are nice.
That's my 22 feet of bookcases. My
Oh,
entire collection.
Wow.
Yeah, that was it didn't take them very long to do it. Just one day. And but it's been double secured, and I was looking for quality, something that would hold up.
It's screwed to the wall, huh? So it doesn't through the studs.
In multiple places, yes.
Good. So it doesn't tip over in an earthquake.
And no, it ain't going anywhere. The books will fall out, but the bookcase ain't going anywhere.
Now
No,
you got the job of sorting all the books, right?
well,
By category or something.
well, what we did was we had two big tables, and we had the books already sorted by author,
Oh,
just just by alphabet, all the A books, all the B books, all the C books,
mhm.
and that kind of thing. And then we just put them out on the table and put them in alphabetical order, and then just so all the same authors are in the same place. So all my Asimov books are in the same spot, in the same cubicle.
Wow.
But that's more than 2,000 books up there that
Well, you got something to do when the TV quits working.
I've read all of them. That's the problem. But no, I joined the science fiction book club in 1971, and
Oh,
I've been, and getting books for Christmas, birthday presents. What do you want for Christmas? Something to read. And then I discovered ebooks, and now I don't buy books anymore.
So do you have a favorite scientific or science fiction book or author?
Yeah, Anne McCaffrey and uh Mercedes Lackey. Both of them. The dragon books, Fern. I've also got the complete set of Harry Potter too. But I have a few nonfiction cookbooks, stuff like that. I've got a lot of those coffee table books that people buy that have pictures. I have a lot of the Hubble, the Hubble telescope.
Uh,
Yeah, I'm waiting till they come out with a coffee table book from the new one, the new telescope that they've got out there. That's and I like to collect books about trivia. Why do fish drink water? Fish don't drink water. Well, they ingest water when they eat, but they get their water through their skin. So yeah, if you ever wanted an obscure fact, I can look it up. Wait, but now you don't need a book. You can just ask Google or ask what's her name. I don't want to say her name out loud because then then it'll come on. They had a commercial on TV not too long ago where they were asking you know, the machine to answer a question or play a game.
I
And
saw that. That was really good.
and it would set mine off every time.
Yeah.
And I would have to go stop.
Yeah. There's a Saturday Night Live skit they did about the Amazon voice assistant that is just absolutely hilarious.
Oh, I'll have to look that up. Yeah, because I was doing that the other day. I was telling my daughter about, asked her if she'd ever seen the cartoon movie, The Incredibles. And she hadn't. And there's a little skit, a little scene in there in The Incredibles 2, where they've had a little baby named Jack Jack, and the baby has like 22 different powers, and it has an altercation with the what's the name of the animal with the with the mask?
The raccoon, Linda.
Raccoon. I don't know why my brain just won't wrap around that word. Anyway, the baby has an altercation with the raccoon, and it is, it's only about 2-3 minutes long, part of the movie, but it's really funny. Just put in Jack Jack and the raccoon and it'll come right up on Google, YouTube, whatever. So what's on the agenda for tonight?
I'm going to do a presentation on probing electronics.
Hopefully it'll help me out, Mike. I pulled a good one the other day with that Allicrafter SX43. I started recapping it. I took out the selector switch, which selects from AM, FM, phonograph, AVC, automatic, and manual. And when I put it back together, also found a couple diodes in there that were across the AM detector tube, the 6H6. Well, I pulled those out because I knew they weren't supposed to be in there. And I got all done, put it back, well, not put it back together, but fired it up. And guess what? It don't want to work very well. It was working before I took it apart, fairly good. But
Do you have any extra pieces?
yeah, resistors. I figured out I left out a capacitor because I have another one that I can go by and look at. Anyway, I spent a whole day or so on that thing trying to figure out why does it sound like that. And the AM barely works, if at all. So today I finally says, well, I'm going to check that little 6H6. I put it in the tube checker. It's must have been filament opening or anything because it was deader than a doornail. So I put another one in there. It came back to life. It worked pretty good.
Yeah,
So I
something
found it.
I
The
found
funny,
this. Yeah, go
the
ahead.
funny part was that FM still worked because it took a 6AL5 for the ratio detector in that one. So the FM worked, but the AM would not work hardly at all. Boy, I felt stupid. Anyway, the guy, instead of replacing the 6H6 before I got it, just put a couple of diodes across it. So that made it work good.
Oh,
Out. But now it's back to original. Don't have the diodes in, it's working. So lesson learned.
Yeah.
I just put in the chat the link to that SNL skit on the Amazon.
Oh, thank
voice
you,
assistant.
thank you. I'll write that down. One of the
Yeah.
things that I found in my husband's collection of books, it's an article by Mark Opat or Oppet or however. Is he a member of your club or ours? The one up in Seattle, rather. Anyway, it says replacing capacitors, the secrets you need to know. And it's it's 3 double-sided 4 double-sided pieces of paper. So it's an 8-page, eight page written up.
Wow.
Has a little diagram at the bottom here. Anyway. So,
Well,
It is
usually I
nice.
don't have any trouble, Linda, but
yeah, that's a nice. Well, I'm just saying it's a nice reference document, for people that might not be familiar with replacing capacitors.
Well, maybe
Yeah.
we can get it scanned in and added to the website or something.
Yeah. I was gonna try and make it to the Saturday meeting, and I don't think I'll be able to do that. We're going to high tea. And it's
Where's
our
You take the ferry?
I'm
Victoria?
sorry.
You're taking the Victoria Ferry?
No, we're not going up to Canada for it's a little
Oh.
restaurant. It's a restaurant in somewhere in Portland that serves
Ah,
special, it's quite an elaborate it's my Christmas present.
What hat are you gonna wear? You have a
I'm
really
sorry.
you have a really cool hat to wear?
Yes, I have a fascinator.
Awesome.
A nice little concoction. Feathers and all kinds of fun stuff.
It looks like we lost someone, but if you want, I can go ahead and start my presentation unless you want to wait a little bit longer.
Yeah, that's fine.
Well, I noticed that Franklin didn't send out a link for night. It's the same every night, but I went ahead and just updated his last one and just sent it out.
Okay, maybe we can give it a couple more minutes then.
mhm. Yeah. I was hoping to see the masked man. Frank, Christian, I never seen his face.
He was here earlier. He
He was
dropped
the
out.
one that dropped out. He had a tube there. No,
Uh-huh.
Christian doesn't like to be recorded,
Oh,
so that's why he doesn't put his face up there.
well, he attends the Passaro ones and we don't record it.
Well, he just doesn't like to put his face up there. It's all right. He's
Oh.
probably doing something while he's.
So Mark Opad is not one of the members of the club. He's a vendor.
Oh, okay.
He
All right.
has a lot of volume controls and miscellaneous parts and stuff like that. He's kind of the go-to guy. I think he's back east someplace. I forget, Ohio or someplace.
Okay, I knew. I probably remember him from the directory that I put together for the Seattle Club had some resource. Had a resource page, where people could buy bits and pieces and parts.
Yeah, he's very active, has a lot of stuff, especially volume controls.
Yeah.
Oh, I'd like to get rid of some. I probably got 2 or 3 5-gallon buckets full.
I'm sure you need to talk to him, but
Yeah.
Yeah.
a
Find
lot
one
of his are new old stock.
Yeah,
Oh.
find him in the directory, Jerry.
Yeah, mine
Anything 2019, 2018, 2017, those
Okay.
directories will
Mine
have,
are- Mine
lot
are
of
old
it.
salvaged.
yeah. No, if they work, some people need those kinds of
Mhm.
resources. People are always looking for knobs and the fabric. There's a company out there that makes the speaker, the speaker fabric. And
Yeah.
His website is oldradioparts.net.
okay.
Hey, Myron, do you have the sketching for that Philco radio of yours that I'm working on?
I don't think so, Pat. I think I gave you everything I had.
Oh, because I don't remember you gave me a sketching with it. There's a couple nail holes where I think it went to on the right side of the radio.
It's been so long, I forgot where I got that thing and whether it had that or not.
Hmm.
I don't think I have it around loose, but I appreciate you
Oh.
working on it.
Do you have any knobs for it?
I think those are just the standard little flowery looking Philco knobs, aren't they?
Mhm.
I don't think I have any, but it's been what, 2 years now or something? I really have
Looks-
no idea where I got that from.
You bought it at an auction. I think you paid like
Oh,
$1 or $2
yeah.
for it.
Yeah, I expect you're right.
So are you gonna be at the meeting Saturday?
I'm planning to, yes.
Oh, okay. I'll bring it then. I'll look for some knobs. I can't guarantee I've got rosette knobs.
And I have that GE ready to go back to you. It turns out that the buzzer, that's a feature. You could have it turn on the radio, and then if you didn't turn it off within 5 minutes, the buzzer would go off.
Oh, really?
So it actually is not broken.
Oh, okay.
I
thought
read
you
it.
said the
I
clock
had to-
motor was bad.
Well, it was because whenever I plugged it in, it would buzz. But
Oh,
now that I fixed it so it doesn't buzz, I mean, I turned off the alarm basically. So I read the owner's manual. It has instructions.
oh,
And it was like, oh, you can set it to buzz.
oh, cool,
So
cool.
yeah, it actually works.
Oh, wonderful. You want to have a peek at what your radio looks like?
Oh, sure, that's cool.
All right. Well, I'll be right back.
Yeah. Mike, you ever tried making some Philco knobs?
No, I've just done the Crosley, and then I did the Silvertone thing. But I can do pretty much anything if I have enough time and patience to sit down and cat it out. If I have one I can mimic, I can usually do it.
Mike, you make knobs?
Well, so I've got two different 3D printers. I've got
Oh,
a resin printer and a FDM printer, and I'm actually looking at trying to justify the price of buying a super nice FDM printer. And I have the CAD skills to be able to pretty much replicate anything. That's the hard part is, drawing them up. But yeah, I can draw them up and print them. And I've done a couple for Pat.
Yeah, that looks great, Pat.
Well, don't look too carefully. Do you have before pictures? Because this radio was pretty bad. If you remember how
I remember, yeah.
it was all wiped out in front, and I had to rebuild the bars there and stuff. So don't look too close, but I think it came out pretty good.
Yeah, it's really nice. Really nice. Yeah, the top was crunched. It had a bunch of
Cracks,
bad
yeah.
spots.
Yeah.
Yeah.
Well, so that's not a $2 radio anymore. It's like a $5 radio.
Yeah.
So, all right. Sorry it took so long. Last year the weather was so bad. I did not work on one wood radio at all last year because it went from basically cold, wet, and then, it was, the weather turned. And so I didn't get to work on any wood radios.
Right, so that had the little metal piece that goes around the dials, goes around the knobs, is that right?
Only
Yeah.
on this side
Huh,
where the little
I
pinholes
see, yeah.
are.
Yeah,
So, okay,
interesting.
well, don't look too close.
Looks great.
Okay,
Thank you.
no problem.
I actually have one thing to show before I start on the presentation. I went to Galen's estate sale and I picked up two things. Actually, I picked up more than that. One of the things I got was COVID. So I'm still recovering from that. But I also picked this up, which I'm much happier to have. It's actually a mechanical coil winder.
Yeah, and they came with a whole set of cams.
Yeah. Yeah, so I ended up buying it because I thought, well, if I'm doing the electric one, see how the old one worked, and it gave me some new ideas. I'm going to try to incorporate in. They do some pretty cool looking coils. I don't know if you can see here. that in focus? They do a honeycomb coil because you've got a cam down here. Let's see, trying to do this backwards. When you crank the handle, there's a little cam and it pushes this bar, and the bar goes back and forth, and so it'll actually build a honeycomb. So I'm gonna make sure that mine does all of that stuff too. So I thought that was pretty cool.
Yeah, it has the turns counter too. That's reduction gear.
Yeah. So anyway, I bought that, and it was all bent up and wouldn't turn, and I straightened the shafts and lubed it and got it all back together. Had to do some retapping and things like that. But so now I've got a mechanical coil winder to go with the microcontroller based one. So we'll see which one's better at the end. Oh, hey, Mike. I'm glad to see Mike McCrow here. No bingo tonight.
No, there we go. I was muted. Yeah, good to see everybody. Yeah, no bingo tonight. I just went down to the coast and played golf, so I got out of the hot weather. It was really nice in Lincoln City. It was like 68 degrees.
I have a friend in Tucson that said Friday's supposed to hit 113.
Yikes.
Yeah, but it's dry heat.
Yeah.
Probably still fried egg.
Yeah, no kidding.
So, because I've got nothing better to do than sit in my room quarantining, I came up with a quick presentation on probing, and hopefully you guys can help improve it as we go here. So I'll do a screen share. Can you see that okay?
Yeah, I'm trying to.
Oops, let's see. Oh, come on. I'm trying to move the people out of the way here.
That's what I was trying to do.
There we go. Okay. So everybody can see that?
Yeah.
Okay, perfect. So when we're looking at probing electronics, it's basically how we can get any of our test equipment connected to the device so that we can measure it and take accurate measurements. And it's really important that the test equipment not interfere with the device we're trying to test. And that's a really big deal, especially when you start dealing with higher frequencies and things like that. It's also important to isolate any harmful conditions, either that could affect the person working on it or the test equipment. And then the test probes are really the interface between the test equipment and then the device under test. And they can do a lot of things like balance impedance and do things that the probe itself can actually help make things more accurate. And it may actually provide some signal conditioning to it. I view that there's really three basic types of probes. One I consider to be an indirect probe. This would be something like current transformers. You know, this is an example of one here, an amp clamp, to where you're not physically touching anything. It would go around the wire. Hall sensors, which are, they'll detect magnetic fluxes, again, is a non-contact type thing. Then, of course, there's the non-contact voltage probe like this one here we've talked about before. Field strength meters, grid dip meters, those kind of things are indirect. So you're not actually physically touching anything. It's based on proximity or something of that nature that is, now they can still have some loading associated with what you're testing, but in general, they're indirect. Then there's a huge class of passive probes. And the simplest obviously is like a direct probe that you might have on your voltmeter or something like that, to where, you know, it's literally a wire with a usually a sharp point or a hook that connects to the things that you're working on. But you can also have things like low capacitance probes. These are used to help reduce the loading of your test equipment. So your test equipment isn't actually loading the circuit under test due to capacitance. There's attenuating probes. Attenuating probes will actually take like maybe a high voltage or it could be any voltage and actually reduce it down to make it closer to what the test equipment can work with. There's a demodulator detector probes. There's RF probes of different types, decoupling probes, which might, you know, have capacitors or something in there for a bypass. And there's actually a couple different forms of high voltage probes. There's a resistive style as well as a capacitive divider style. And then there's, of course, resistive decoupling and isolation probes. So there's many different types of passive probes. Then another class is actually active probes. And probably the best example of this is the differential probe that's used with an oscilloscope. And what that probe is, they're usually or quite often remote or secondary power. So they're powered by something. Usually you'll have a power supply or something going to these probes. And this differential probe or any of the active probes will do a lot of processing itself before it sends it to the test equipment. And there's some active RF probes that will allow you to take very high frequencies and get it into a test equipment that's much lower frequency, things like that. Any questions or comments before we go? I'll take a quick pause here.
I've got a probe I can go and get it. It's a big long probe like this, and it doesn't connect to anything other than it has a point on the end. And it's for very high voltage, like for working on television sets.
Yes.
And so what class or what category would that one fall into?
That I know the one. I should have brought one up myself. I've got one downstairs. That's usually a resistive high voltage probe.
Okay.
And this one right here is actually a small example of one. This is a high voltage probe. They'll go to, I think it's written on it, 4,000 volts. And inside here, there's a big resistor. I believe the company Pomona used to make the, I know I had a Pomona high voltage probe. And I know they were real common, and those were all resistive. They just have they're usually like about 8 or 10 inch long, you know, high voltage resistant resistor inside of it that'll step that down so you could use it to a regular meter.
Okay.
But, you know, here's just a small collection of some of the probes I have. For some reason, I don't know why it happened, but a lot of the green colored ones, those are usually your demodulator probes. The yellow ones quite often are the direct probes. These will be like a resistive probe here. Let's see, this one here is a low capacitance probe. You know, and they come in all different shapes and sizes, and that's really kind of what I wanted to show here. And the worst part is, and we'll talk a little bit more about this, but a lot of these are unfortunately matched to a specific piece of equipment. And so you do need to be somewhat careful just mixing and matching, because as an example, an RF probe for an oscilloscope isn't exactly the same thing as an RF probe for a VTVM. And so you do have to be careful there, know what it is. I've actually taken all of my probes apart and looked at the schematic of it to see, you know, I built my own schematic to see what was inside of it and then labeled it so I know how to use it properly. And I'll explain why that is in a minute.
On the demodulating probe, is that actually a probe you would use to check what your demodulation in a radio is, or is that just mean that's a classification of that probe?
Good question. So the demodulator probes, they actually can perform two functions depending on what it was used for initially. But like this one's called a crystal probe here, and this one actually does the same thing. What both of these have is a 1N48, I believe, which is a germanium diode
Mhm.
in series with it. And it can be in parallel depending on what they use it for. And so if this came with a signal generator, yes, you can actually take this and then you could probe your RF, and what it's going to do is demodulate it for you going into your signal tracer. I said
Oh, okay.
I said signal generator, I meant signal tracer.
Tracer, yeah, okay.
So something like this, yeah, that would demodulate it for you. So you could actually go into your RF, touch on that and then listen to the audio coming out.
Oh, wow, okay. So it's gonna perform the same function as your demodulating capacitors would. So then you can demodulate your RF and then just give pure audio out, correct?
Exactly. Yep.
Okay.
Yeah. Because what it's doing is it's giving you that diode.
Yeah.
Now
Okay.
they also use.
Oh, okay, it's got, yeah, the built-in diode.
Yeah, and that's what it's there for.
All right.
Now they also use it, and we'll talk more about this in just a second. But they also use it for hold that thought and make sure I address FM alignment and old oscilloscopes. Don't let me forget to talk about that, and we'll
Okay.
talk more about the demodulator probes. Any other questions here or comments? I rely on you guys having all the right answers. I just put up slides for questions. So let's talk about an RF probe and what they're used for. And this is another way to use an RF probe. So RF, the problem is when you look at a meter, as an example, a DMM, a VOM, a VTVM, it doesn't matter as long as it starts with a V or a D. The problem you have is when you're measuring AC, alternating current, most meters are really limited to the frequencies that it will be accurate at. If you're looking at the digital ones, they've got to do sampling. And so, if your frequency gets too high, they're not going to work well. In the older days, before you had the digital sampling and things like that, again, the high frequency wouldn't work very well. And you might be limited, it was really made to measure RMS voltage for AC current on your power lines, 60 Hertz. But, it'll work okay, maybe up to 1,000 Hertz, sometimes 2,000 Hertz. But you start getting beyond that and your RF value or your RMS value is going to be completely off base. It's not going to be a valid number. And so how do you fix that? How do you measure RF voltage? Well, they actually make an RF a meter, a voltage meter for RF. But the other way they did it was they did it with a probe. And what they did was they just put a diode across it, converted it to DC, and then you could measure it on your DC meter. How cool is that? So,
Oh, wow.
that's what the RF probes do, is they just convert the AC to DC, and then you just measure the DC. Well, that's nice, but the problem in doing so is if you convert it to DC, well, now you're going to get a DC voltage, but that DC voltage still is not the RMS voltage, right? Because if you remember, it's 1 over the square root of 2 times the peak value. Well,
Right.
so that's not going to exactly work. So what they did was they built a probe that has the diode and we'll say a 4.7 meg ohm resistor, the M meaning meg, not K. So they put a 4.7 meg ohm resistor in series, and then this is the end of your probe right here. Well, now the cool thing is, like a VTVM or even a DMM might be an 11 meg ohm device. And so in reality, this is your meter right here, 11 meg ohms.
Oh, okay.
And so now you've got 15.7 ohms, you know, and you're going to be actually measuring across here. And so this voltage divider ends up being it's actually 0.7006 or something like that. But guess what? You're actually measuring 0.707, which is what the RMS calculation is. So they're using the meter as a voltage divider. Your circuit, you know, your probe itself is nothing more than a resistor and a diode, a resistor and a diode. But the cool thing is, because the meter also has internal resistance, you know, the impedance of the meter, this works out to be, now when your meter shows a value, it's actually going to show the RMS value. Now, isn't that cool? I think that's cool. Now,
Oh,
there's
nice. Nice.
the problem with that is, what if your meter isn't 11?
I was just thinking that.
Now the good news, most VTVMs and most DMMs are either 10 or 11 megohms, and so that's great. But if you're using like a Simpson 260 or a a triplet 630 NA or something like that, you know, that's 20,000 ohms per volt, and you tried to measure it with an RF probe, you're not going to get the right numbers, because, you know, this value of resistance is going to be very different. And so you would actually want a different resistor inside your probe. But that's why it's really important to know what the probe is using and how it's being used. But anyway, that's how RF probes work. That's the other use for even a demodulator probe, because, you know, if a demodulator probe is set up this way, it can act as a detector, because this is going to cut off half of the waveform for you. But you could also use this as an RF probe if you wanted to. But anyway, that's why they have the diode and the resistor. And just knowing that allows you to do quite a bit. Now, let's say you got a probe and you crack it open, you go, oh crap, mine's not 4.7 megohms, but my VTVM is 11 megohms. What am I going to do? Well, you can still use the probe. Just be aware that your RMS value is not going to be dead on accurate. You know, and if this is a 3 megohm or a 10 megohm or something like that, you know, if it's a 10 megohm, you know, you're going to be splitting the voltage between these two, right? So this is going to be essentially measuring 0.5 rather than 0.7. So you could either do some calculations, or you could say, you know, I'm measuring low, so I'm probably okay. You know, it depends on. But again, this is all about, if you understand what's going on inside your probe, you can use it to your advantage.
But like you said, if it's proprietary to the device, then it's already going to have the correct resistor set up for the resistance that's in the device. So then you're going to come up with the correct RMF voltage then.
Exactly. The problem is, at least it's been my experience, and maybe you guys have been luckier, but anytime I buy old test equipment, usually the probes aren't with it. And then I go buy this big friggin' box of wire, and I find a few probes in there. And so now I've got this mismatch of probes and test equipment. And so I'm always trying to figure out how to pair them together. But the nice thing is, you know, I can get pretty close, or I can even go tweak the resistors if I want it to be dead on accurate. So the demodulators, you know, they'll either, they can demodulate or detect. And again, since voltmeters can't measure high frequencies, you know, they'll use that half-wave rectifier to do the RMS like we talked about. But the other problem is, and this is where I wanted you to remind me, I wouldn't forget to talk about it. The early oscilloscopes actually had a bandwidth problem. And they didn't display RF or high frequency signals very well. You know, they just couldn't get up that high. And so they used demodulator probes to remove the carrier out of it when they were doing FM alignment. So they would use the demodulator probe strip out the RF, and then they could just be looking at the FM that they cared about that was the signal. And so they would do that on old oscilloscopes that didn't have the bandwidth to be able to look at the FM signal with the carrier. But nowadays the oscilloscopes are well above the FM frequencies, or even a lot of the HF frequencies. And so, you know, in that respect, you don't really need the RF probe, but you know, you might be following an alignment procedure that requests that. And so they'll actually use that demodulator as a way to strip the carrier. You know, and this gets back in, because we're
Right.
dealing with old stuff. A lot of times you're dealing with old manuals that are, and old procedures that were built with old test equipment.
So if you're doing a, let me see if I understand this. So if you're doing an discriminator alignment, you peak your IFs, let's say at 10.7, then when you want to do the discriminator alignment so that you're aligning the what is the frequency modulation to be centered, then if they strip that away, the high frequency, then how is that accomplished then?
So I'm going to let someone else speak, because I don't have an answer to that, but that's a good question.
Unless
And it might be that you can't
Well,
do this all the time. You know, it might be for certain parts of the alignment, but maybe with the discriminator alignment, you can't. I don't know.
yeah, because usually what you want is a center line on the frequency modulation so that it's centered between, you know, both sides of the modulation up and down to where that way it's aligned properly.
So what you might want to do is read this link here.
Uh-huh.
There was a really good discussion about this with the FM alignment under that Antique Radio Forum.
Okay. Oh, yeah. So that'd be good.
I don't, like I say, I don't have all the answers. A lot of times I just have questions.
I think it would just be, you're trying to peak the IFs, you know,
Yeah.
not the discriminator, but, you know, because otherwise you don't have any good way to peak the IFs, right?
Well, yeah, you
think
could
that's
peak the
actually what they
IFs.
were talking about. Yeah.
Because 10, you know, the IF is going to be a lot lower.
10.7.
The 10.7, yeah, or it could be less, but it's going to be a lot less. And depending on your equipment, you should be able to peak the IFs, you know, even with a regular RF signal generator. You know, they'll usually go up to that. The discriminator.
I think they were talking about the IFs in that forum, and you know, it would make sense to me that if you keep in mind, you know, at the IF, you still have the you know, before you do the discriminator and all, you're going to have the carrier as well as the IF signal, right? And in the old oscilloscopes, that carrier is going to cause you problems. You're not going to be able to see the IF with all the carrier going on, and because it can't handle the bandwidth. So if you use an RF probe there that basically is stripping out the carrier, that's just going to leave the IF, which is a lower frequency that would hopefully show up.
That was my point. And that even in the discriminator, you're just trying to peak that. I mean, you're just trying to center line that, right? And that's on the IF too. So that's not really the high frequency that you're dealing with. It's
Right,
just the IF.
Right. But the problem, I think, is if you're using an oscilloscope, if the carrier is still there and your oscilloscope can't handle it, then when you start having the problem.
That was the point. Okay, I get it. All right, yeah.
But in today's test equipment, that shouldn't be as big of a problem from what I understand. Myron, is that the way you understand it too?
Yes, I think so. I don't know, you know, did early scopes go up to 10.7 megahertz? I'm trying to remember. I think those giant tech scopes would go to 50 sometimes, right?
Yeah. but
Typical
not 100.
serviceman's
And
point
that's
to
the-
5 megahertz.
Yeah. So here's some tips and tricks that I wanted to kind of throw out. So keep in mind that not all test probes are going to match a specific tester. You might have something labeled RF that might be for a signal tracer, which would be very different from an RF probe going to an oscilloscope. They're actually, they could have different internals that may not work the same. Or even another one going to a VTPM, because it's matched to that. So, just don't assume that an RF probe is an RF probe. They may have different internals for trying to do different things. When measuring high frequencies, it's really good to use probes that have shielded or coax. If you're using things with banana jacks and individual wires, you're going to possibly introducing more trouble that you're not actually going to be able to see the signals properly that you want to see, especially if you're looking at oscilloscopes or even, if you're trying to do an RF probe or something and you're using something that you cobbled together, or maybe it was designed for something a little different. If it's not shielded or coax based, you could actually be measuring things you don't think you're measuring.
Mm.
And again, and this to me, I'm a little surprised, and maybe I shouldn't be, but almost no probes have any form of a decoupling capacitor built into them. Very few that I've ever seen. And it's really important, especially for people working on vintage radios. The AC signal may be riding on top of a very high DC offset. And it's really good to put a decoupling capacitor between your probe tip and the thing that you're probing. I strongly recommend that, and I'd like to get feedback from the group. I'm assuming everyone does that. If you're doing like audio frequencies and stuff, you can get away with like a 0.01 microfarad, something like that. If you're doing RF frequencies, you don't really want to use a 0.01 micro, excuse me, because that capacitor is going to act a little bit too slow, and it's going to null out your waveform. You want to drop it down to somewhere in the 10 to 100 puff type capacitor for measuring radio frequencies. But I highly recommend putting those in series with your test probe. And it's even a good idea to put them in series on the ground lead even. There's nothing wrong with putting them in series on your ground lead. Comments on that at all? In fact,
I've not working on AC radio. I mean, AM radios or haven't used a probe to demodulate the the RF ever. And so, but you're saying you highly recommend that and that is when you're measuring, because you're talking about the AC having a high DC offset, and you want to use a deep coupling capacitor in series to block the DC.
right. I don't, if I'm, as an example.
I see what you're talking about. You're talking about when you want to go ahead and hook up your oscilloscope or hook up a meter. Is that correct? So you want to you're blocking the DC out. Okay.
Yes, I'm preventing the DC to getting into my test equipment.
Okay. Yeah, no, that makes sense. For instance, like when you have, you'll usually have a built-in capacitor that's going to block the DC out, like an ACE, like for instance, an audio coupling capacitor, and where you have DC voltage in coming in on the plate of the second audio tube, and then you want, or no, a better example is on the first audio. I mean, where the plate voltage coming off is high voltage DC, and then there'll be an audio coupling cap in there between there and the grid of the second audio. So that way you're not going to put all of that high DC voltage in on the grid in the next two. And so it is just a matter of knowing where you want to hook up your equipment at. You don't want to hook it up into that high voltage DC when you want to check the signal coming in. You're going to want to put it over on the other side where
Well,
you don't have all
Actually,
the voltage.
that's, yes, that's true, but that's not what I'm saying at all.
Oh, I'm sorry. Okay.
No, but
You
this
didn't
is
get it.
really good. This is really good to clear up. What you're absolutely right. When you look at between two stages, you've got the plate going to the grid, and there's usually a bypass or decoupling cap
Yeah,
between the two so that the high voltage plate DC won't get into the grid of the next stage.
right.
But so in theory, if that decoupling cap is working great, you shouldn't have a DC component at the grid. But the thing is, you don't know that, and you don't want to, you will always want to protect your equipment. So what I'm saying is
I see.
on your probe itself, add an additional capacitor to it
Oh, yeah.
at the end. So when you touch the grid or the plate,
Mhm.
they're both getting blocked by a separate capacitor that is on your probe.
Right.
If that decoupling cap between the plate and the grid is leaking,
Mhm.
and you touch the grid, you might be still getting a DC offset.
Okay. No, you're right. And I see what you're saying now. Yeah. And I've done that. I have a Rigel waveform generator, and that's what I've done is I put because by advice of Blake told me, and I put I think it was a 0.01 capacitor right in the probe coming out of there. So then that way, just like you say, you're in case the equipment you're working on is leaking or something, as a protection there. Yeah, no, I see what you're saying. That's a great idea.
And the 0.01 will work well for the audio frequencies. If you're probing the same way in the RF, I would change that capacitor somewhere in the, say like 50 puff or something like that.
Oh, yeah.
Mhm.
Yeah.
Now, I have a question, Mike Farabee.
Yes.
That 0.01 microfarad capacitor, is polarity important?
Yeah, ideally you want non-polarized, because you don't know what you're going to be probing. Is it going to be, you're going to have AC signals there. You could have a negative bias. There's all kinds of different things. What I use is usually like a 600 volt film capacitor.
Now, in the old antique radios, many times it's a wax capacitor with a ring on it for, I think that's the negative side. And
No,
that's,
it's not.
no?
No, so the old paper capacitors,
Mhm.
the black line actually does not specify negative. Yeah, there's probably some exceptions, but the black line does not specify negative. What it specifies is the outer, the capacitor is rolled.
The outer
right?
foil.
And it's specifying which end the outer foil is connected to.
Does that go toward the grid or to the plate?
That someone can
Good
help me
question.
here. That usually, normally what you do is you take the outer foil, if it's connected to B- or ground, you usually take that outer foil to ground because it acts as an additional shield. Is kind of the way it was explained to me.
Yeah, so if it goes between a grid and a plate, then it'd probably be toward the grid.
Yeah.
Yeah, that would be, you would think that would be the more sensitive of the two. Let's see.
So I'm thinking when I hook a test meter up to it, I'd put the outer foil toward the meter.
No, that part doesn't see the. Yeah, I wouldn't use a paper capacitor in this
No.
situation. I would probably go with the Mylars or something like that.
Yeah.
The,
I've been
the outer shield part goes towards the B plus, away from the grid, Mike.
Away from the grid, okay.
Yeah.
And that's actually because the grid is going to be more sensitive, and so you want to shield that, right? If you want to think of it that way.
Well, he said something about closer to ground or something like that. The B plus is closer to the ground than the grid. At
Okay,
Oh.
least that's what Carlson's lab says.
well, if Mr. Carlson says it, it's gotta be true. And that would actually make the most sense to me, because if I think about a paper capacitor and, being the outer as a shield, it's really not a plus and a minus, right? It's the outer, that outer layer is acting as a little bit of a shield. I think I
Yeah.
would want to shield the grid more than I would the plate, because I would think the grid would be more sensitive. Now that might not be true, but that would be my initial thought. But I honestly don't know. Most of the time I see them, see, what do I think? Well, I mean, Larry will know better than anyone, or Myron,
Well,
but great question.
on your oscilloscope, I just kind of wonder, because is there any protection there? If you're measuring an RF frequency, where you want to show high frequency RF, on your oscilloscope, then you just normally hook it up and hook up your probe, and then you have your switch on there. It was either 0 or times 100. Are those probes that are on your like Tektronix, for instance, oscilloscope? If you're using that, are those all already built in?
Okay, so what you're talking about, I think, on the oscilloscope probe is the ×1 × 10.
Yeah, 1 × 10. That's right. Yeah.
Yeah, that's actually an attenuator, and it's literally nothing more than a resistor
Okay.
to reduce whatever the input voltage is, so that your scope will be a factor of 10 less.
Yeah, but
Then
I
and
kind of confused that, because what I actually meant was, I didn't mean the attenuator. I kind of had an idea what that was, but I mean, are these probes that you're hooking into your oscilloscope, are they protected with these 100 puff caps in there for high frequency
no,
already, or no?
no, they're not. Now, with a lot of test equipment, especially well, even the older or the newer test equipment, you will see that there will be a lot of times a switch that will say DC coupled or AC coupled. And actually, I'll use my favorite, the Simpson 260 meter. If you notice on the Simpson 260, there's a pin, there'll be common, there will be the plus, and then there'll be one called output. Well, that output is not actually output. That actually just is a capacitor in series going to the plus side. And so you can actually shield a lot of times, you can decouple the high DC voltage by using the AC coupling or that output connector on your VOM. And there, you'll see that in quite a bit of a test equipment. Some test equipment actually has things built in, but the thing you have to be careful of is you also have to look at what the voltage rating is of that capacitor internally. I think like my scope, I looked it up, it was like 300 volts or something like that, or 400, and if you're going beyond that, you still wouldn't want to trust that capacitor to handle it.
Okay.
But yeah, actually, I should have put that in here. There is the AC/DC switch, or like with the Simpson, the output terminal that you can use to insert the capacitor in for you.
Oh, okay.
And if you look at some of your equipment, you'll see that.
Mike, they do make low capacity probes for scopes too.
Yes, yeah. In fact, in my picture here, that's what this thing is. This is a low capacity probe, and I think one of these was too.
So that'll Okay, so it's low capacity and it'll bypass, high pass. In other words, it's a high pass.
Yeah, so what
for
what those
high
do,
audio,
what those are doing
or, I
is
mean, high frequency.
they're they're providing to the device under test a very low capacitance, be in the, and so you're not loading your circuit. Because now the good news is most oscilloscopes and stuff are very very high high impedance, very low capacitance, but you can even get probes like what Larry was mentioning that will make them even lower.
Okay.
And that's where like the differential probe, things like that can be used. Some other things is you always want to isolate your device under test. I know you guys know this, but using an isolation transformer. But I did want to point this out because I've seen this talked about in the past. You always isolate the device under the test. You do not isolate your test equipment. Do not isolate your test equipment. Isolate your device under test. Now, there are cases to where this couldn't happen.
How about if you isolate both of them?
No, you don't want to do that.
Tell me why.
The reason why is there's a lot of test equipment, especially like oscilloscopes, that that really require on the earth ground for shielding. And if you isolate that, you're breaking that whole shield. And now that Faraday cage, that was built in, being tied to ground, no longer exists. And you can actually see, especially with high frequency stuff, you can see all kinds of noise and things like that go crazy.
Never had a problem with it because my bench is isolated from the mains and my test equipment is isolated from the bench. And I have no noise problems.
Your test equipment is isolated.
Imagine, if you
You've
will.
isolated both.
Yeah, so you've been over here to the place, over here to the
Yes.
house. That entire 16-foot workbench is isolated from the mains.
Yeah.
And then the test equipment is isolated from that.
Yeah, it's not, if you do any reading, you'll find it's not desirable to do that, mainly because some equipment really wants to have that earth ground. Not everything needs that, but some of it is, it's good to do that.
Well, I will respectfully disagree with you because I err on the side of safety, but I do understand the noise component, being able to bring that to the ground, but not had a problem with it here.
Yeah, and unless you're doing super high frequency, you may not. And and most of the stuff, I agree with you. Is probably not going to show up. There it is an additional safety, especially if you're isolating both. But the thing is, you don't want to be plugging your device under test into something that's not isolated and then only isolating your test equipment.
Absolutely.
That's the key point.
Absolutely.
Yeah, you could alternatively, like what you're doing, Blake, isolate your test equipment additionally. And the only thing you just have to be aware of is you could be getting some extra noise because of that. That's the main reason.
Yeah.
And actually what you're doing, there's some possible good reasons to do that because you could be adding additional safety to the user to where you're not going to be doing that. Now the other danger in doing that, and I don't know how this works when you've got both of them isolated, so I have to think about this a second. But one of the other dangers in isolating your test equipment and not your device under test is if you isolate your test equipment and then you connect the ground lead of that to the ground of your device under test that's not isolated, well, now your test equipment just became hot ground. And so, you might be really safe with your device under test, but now you go touch your oscilloscope or something like that, and that floating ground on that oscilloscope is now B- or B+ or whatever.
Yep. When we had the gang over here and you had 20 or 30 novices playing on the workbench, it's good to have the double isolation. We found out one night what happens when you do move the same ground, and we made lots of smoke come out of my RF generator twice. Mike McCrow remembers that episode.
Oh,
It
yeah,
wasn't
I
him.
remember
It was
that one.
somebody different, not him.
Yeah, so the key thing here is about making sure that your device under test is always isolated. That's the key. Don't isolate your test equipment thinking you're okay with that, and then you don't have to isolate your device under test. Device under test is number one. If you want to do an additional one, just be aware that you're going to be floating your ground and you could be introducing some additional noise, and that's something you'll have to deal with. Would you agree with that, Blake?
Yes, sorry about that. Had to get off mute.
Yeah, no problem. Yeah, so I think we actually agree, which is awesome. Because I always defer to
Sitting
Blake.
here doing an alignment on an AC radio, and just so you know, it's the device under test is isolated from the generator.
You the man. So anytime Mr. Carlson or Mr. Blake says anything, that's the law. You go by them over anybody else.
That's right. But you're Mr. Hutton. When you speak, I notice everybody gets real quiet. So carry on.
So the other thing to keep in mind is different probes have different impedances and other functions. And so this could also affect the test equipment. As an example, most oscilloscope probes are a high impedance probe to where other things might be set at a 50 ohm probe. So you need to be aware of that. In fact, just recently I was aligning an RF generator, and the RF generator, I had to put a dummy load before I could actually align the thing to get it to work properly, because without the dummy load, I would get reflections and mismatches. This is an example of a dummy load here. This is just a BNC connector, and then it has essentially a 50 ohm resistor built into it. And then in my RF generator, and what I would do is I would put a splitter that I could then connect to my oscilloscope, and then I would put this in there so that I could match it to the 50 ohms to be able to get the right peak readings and things of that nature. It's useful to have some of these. You know, the one thing I'll say about testing in electronics, especially as you start going up in frequency above audio, the whole doggone thing of impedance just really sucks, because you sometimes you have to be aware of it. And you know, like if you're working on TVs, things are 75 ohms. You know, you're working in radio and stuff, it's usually 50 ohms. You know, and old TVs, you could be at 300 ohms. And all of this actually, or even like phones that are what, 600 ohms. You know, so all these different impedances, you do kind of, sometimes it's helpful to make sure that your equipment matches if you're trying to get accurate readings. The other thing I'll say is, especially with like voltmeters and things like that, you really want to pay attention to the CAT ratings on them, especially if you're doing anything with high voltage. Most things are labeled like Cat 3, Cat 4, Cat 5. If you see something with a Cat 1 or Cat 2, you might actually want to stay away from it. But this is showing you basically what the maximum ratings, and there's a lot of stuff associated with CAT. I don't want to just say it's a maximum voltage, because I think there's more than that. But it's basically like the insulation and how close you can get to the equipment and stuff like that. So, you know, look at the CAT ratings if you're starting to do anything with higher voltages. Comments or questions before I go on? So some further reading. I wanted to point this one out. I put some stuff in here on the CAT ratings. This explains the RF probes really good. This was a really nice discussion that I ran into about the use of RF probes and how they can work, especially with oscilloscopes and older equipment. But I found this publication. Are you guys still able to see this? The ABCs of electronic test probes in 1966. This is really a cool book. I highly recommend taking a look at it. The guy talks about, you know, isolation and direct probes, high voltage probes, low capacitance probes, rectifier probes, demodulator probes, special purpose probes, really, really good stuff in here. You know, we were talking about like the high voltage probes. You know, some of these were nothing more than like a big resistor in there. Something like this, to where others were, they actually did some, let's see if I can go way down here. Here he is, you know, he talks about doing this capacitive thing to actually do a capacitive divider so that they could measure the voltage here safely. So anyway, this was a really good, good description of pretty much everything, and he goes into the, you know, the probe construction and you know how to put it all together. I thought it was really good. I was really impressed. People in the '60s actually knew what they were talking about.
And so this is, Rudolph Graf. Okay, I thought it said something about Howard W. Sams. Is that?
Yeah, it's a
Sam's
publication.
publication. ABC's electronic test probes. Okay.
My guess is there's probably at least 3 people on this call that have this book. But anyway, I wanted to point it out. I found it online and I thought it was pretty good. So I wanted to pass that on.
Yeah, that's great.
Yeah, the
Well-
60s had good data. All that pre-millennial stuff was good.
Now, Jerry, didn't you say that you've got a whole bunch of the old Sam's list? Or what, maybe it was Writer or something. I
Who,
thought
me?
you got a whole bunch of those Sam's.
Well,
I have both.
So you might actually have that book there.
I don't know. I don't have that book. No.
Well, something to aspire to. You got something for your bucket list.
I got to find that one.
So that's all I have. Hopefully that's useful to people and somewhat informative.
yes, for sure. That was great, Mike.
You know, it's kind of interesting. A lot of us use probes, but you never really
Yeah.
thought about what was inside that little chunky little box.
Yeah. I know I've got a probe on my, what is it? It's the, not the signal generator, but the,
Signal tracer.
tracer. That's what I was trying to think of. It's a big probe on that, and I'm not
That's-
all sure what
that's a
all is in that.
demodulator Probe as well.
What's that?
That's a demodulated probe as well. 'cause
Demodulator probe.
you're looking
Okay.
at modulated carriers through the front end of the radio with it.
Uh-huh. That makes sense.
I think that one has a switch in it to either include the diode for a detector, or you can switch it out.
Oh, okay. Depending on where you're gonna, where you're gonna introduce or get the signal.
Don't need
Yeah.
to demodulate an audio signal in the audio amplifier, for instance.
No.
Actually, you'll see that. I should have mentioned that in my presentation. I've got a couple of them that have a little switch that'll say, I think it's like RF AF, something like that. And you can kind of switch between it, and that's exactly what it's doing.
That makes sense.
Boy, I have a drawer full of probes and I have no idea what they fit. And I have a whole bunch of equipment and I don't have probes for. And matching them up is I don't know how to go even start.
That's somebody else's job after the estate sale. Yeah, it's, you know, you can actually, I've been somewhat successful starting by brand. The nice thing, the ICOs pretty much all look the same, almost uniformly. You know, if you look at the picture I had, all the ICOs will actually have that one band, usually with a color ring on it. And a lot of them will actually tell you if it's a scope or not. So
Yeah.
big yellow one I had is a Simpson, and it says scope probe, right? Low capacitance scope. So you
Hmm.
can kind of narrow things down that way and actually bin them into separate cardboard boxes to start with.
I do know I have a bunch of those ICO probes. Different colors.
That publication that you talked about by Rudolph Graff, would that help? Like, for instance, Jerry, to help maybe match some of those probes up? Is it got that kind of detailed information in it? Mike?
Actually, I'm glad you mentioned that. I'm going to go ahead and put that, if you're not connected to my website with the documents, I just put a link to that book. Oh, somebody else did also. Thanks, Mark. So there's 2 copies of that book in the chat, but there actually is something that can help. Let me go back here and share. God, if I'm ever going to be able to find it, I don't know. But inside this book, I think I was looking at rectifier probes. One of me gave a list of a whole bunch of equipment and how they were put together.
Ooh, that's nice.
Yeah, I just bookmarked that from the chat.
Oh boy. It's quite verbose. I was just really impressed with the information in here.
Yeah.
Oh yeah, here's, I guess this is for the high voltage ones. He talks about the manufacturer, what range you would set it at with the scale factors and things like that.
Excuse me for coughing
Simpson
without the
2
mute.
Simpson 260. Yeah, it's got all that in there too. Wow.
Yep.
Nice.
So that's all I have on probing. And there's so much more. I mean, that's huge, but I just wanted to give a brief little introduction and just kind of let people know that, there are different probes and you kind of got to be careful if you want to get exact measurements, know what you're measuring with. I didn't make it last week, but I had made the suggestion to talk about signal tracers and some of the additional functions on them. Did you guys end up talking about that? If not, we can maybe do that in a future meeting.
Off the topic, I have, like I said, I've been going through a lot of my husband's books and materials, and I've got a whole bunch of what they call ephemera paper. This is Complete Home Entertainment, the new RCA Victor 1933-34 models, and their pictures
Oh,
of the,
wow. Nice.
and their prices.
Look at that.
So an RCA, the RCA Duo 331. I don't know what that is. $179. So $179 in 19 was a lot of money.
34. Yeah.
1933, 34. So $149. Those are the consoles. The tabletop Model 100, Super Heterodyne, $27.95. So that's
It's probably the monthly payment on a house.
that's the picture.
Not one of those.
Wow.
I have
Yeah.
reproduction dollars for that radio.
Now you can't even get lunch for that.
Yeah.
Somewhere I
never-
read you could take a round trip ocean liner on a steamship, New York to London for the price of a radio.
Yeah, yeah. And then someone took a whole bunch of pages out of the Atlantic Monthly that are advertisements for radios. So yeah, there's a
Wow.
there's a Atwater can.
Well, that's good stuff to have, Linda.
Well, what do you do with
That
it?
is.
Oh, you frame it, put it on the wall.
Show it to people on Zoom meetings and we all go, ooh and ah, because
Yeah, well, they go, wow. Ooh.
Okay, okay. Well, these are things that, and there's some really old magazines. Science and Mechanics. 10 cents. 15 cents in Canada.
Oh, wow.
And on the back, there's an 18 tube 6-in-1 radio. This one.
ooh, a
It's a
Midwest.
Midwest.
59.50.
Sweet.
Yeah.
No tubes. It says less tubes. Terms as low as $5 down.
I can tell you a horror story about a 15 tube Midwest, and it was that very radio.
Oh, wow.
The IF coils, the physical coils are mounted on wooden dowels inside the IF cans. And when the glue goes bad, I would align the radio, it would play wonderfully, and the next morning it wouldn't play at all. I finally found somebody who was an expert on Midwest radios, and they said, oh, you need to take the cans apart, relocate the coils where they used to be, and then glue them back in place. And he was right. That's all it was.
Yeah. And then I have the wireless age from May of 1923.
100 years old.
And it's got, someone with listening to a radio with the speaker. And on the back of this one, they have a radiola.
See if the volume controls nice and smooth.
You're right.
142.50
We're-
radiola.
We're getting to that point that a lot of what we have is 100 years old.
Yeah, yeah. We're no longer collectible. Now they're antiques.
Now they're true antiques, yes.
Right. Used to be just collectibles, and now they're antiques. And
Vintage people collecting antiques.
We're going to have a 100-year of radio celebration. I think that's in November. And instead of having our regular monthly feature, whatever, everybody's supposed to bring in their 100-year-old radios in November. So that should be fun.
That would be.
yeah, I'm going to take a lot of this, the papers and some of the books and things up to the August swap meet up in Seattle.
Oh, yeah.
Yeah.
Linda, are you gonna sell them or just display them?
No, I'm getting rid of them. There's no room. I have no room left on my bookcase. And I don't fix or collect radios. So why should I hang on to something that could probably be of value to someone that needs to repair or someone who collects radios and wants to display stuff. So yeah, a lot of people collect the paper stuff, but I've got a lot of reference books that he had. Too many to they're buried in a box. But anyway, I've got about 4 boxes of books that I'm taking up to Seattle. So a lot of reference materials and things.
Typically, they advertise that swap meet starts at 9 AM and people are already trading at 6 AM.
Well, yeah, as soon as the gates open, and they talked on Sunday that, they used to, the security people wouldn't let you in until 6 o'clock.
Mm-hmm.
And now security says you come in whenever you want. So I think some people are probably going to come in and park and sleep in their cars.
Pitch
You
a
know,
tent.
Oh, they'll let you do that.
yeah, and that you can be there before 6. Let's put it that way.
I
So,
still got a bunch of those rider manuals if anybody's interested.
yeah, I auctioned off Cliff's Riders. Those are gone.
No,
Darn, I needed the number 23 real bad.
yeah, everybody needs 23.
Now,
But you know,
what are
I
the
have-
original? What are riders running these days?
Nothing, hardly
Now-
anything.
I
Because
remember
they're-
volume one back in the 90s was selling for almost $200.
My
You can get
goodness
Get it
sakes.
online now. It's all online.
Yeah.
It's all available online. So, they're not
Anybody have the writer's book that precedes volume 1?
the index? No.
Nope.
What is it?
There was a book that he released prior to volume 1.
Wow.
Oh,
It's only about an inch thick.
I have what they call the red books also. You've heard of those?
Oh, let's see. I'm trying to remember.
Writers put out a couple what they called the red books,
Yep. Those were
red covers.
manufacturers, weren't they? Because there was blue ones and green ones. Green ones, I think, were either National Union or Sylvania, but National Union, I think.
Yeah, I got one of those.
So who are the red ones by? Or are they still
don't-
considered? Are they
I
still
don't
say writers?
remember. But they had different schematics.
Huh.
At Galen's sale, the writer's set went for, I think it was $75. And then when I went back, there was just one book sitting left, and I don't know if the people didn't buy the whole thing or what, and it was $14.
It was really hard to get a hold of volume 26, the last one.
You mean 23?
Or 23, okay. I've got the set, but
Well, I've got volumes through 22, but I have all the in filing cabinets. I've got all of the paper copies of the Sam's Photofax, and mine start at number 1 and go through like 750. So there's a few in the late 60s that I probably don't have, but I think that there was an overlap there, that if you have the early Sam's, that's going to probably cover a lot of the stuff that was in volume 23. Maybe not all of it, but
Does anybody here have the Gernsback series? Volumes 1 through, I believe, 8. They overlap between 30 and 38.
no.
And they're
No.
really good. They have a lot of wiring diagrams in them that you don't find in writers.
yeah, I don't know if I have some of those. Thought I did.
Now, are those writers that are online, are they of good quality where you can read the fine print?
No,
No,
they're 300, but yeah, if you're curious, this is what a Gernsback looks like. You got thin pages, but yeah, they're really interesting. This is the 1932 official radio service manual by Gernsback,
Hmm.
and they're fun.
I have one about that vintage that General Motors put out for their car radios.
Oh, nice.
Nice. I've got a couple of Gernsback books, and that's it. They're out in my shop. I can use them.
I finally filled out my my Bateman's. I was missing 2 volumes, 1957 and 1962, and darn if Scott Thomas didn't spot those very 2 at a sale, and he picked them up for me. So I'm now good from all the way to 65, I think. and they go to 69. I don't really care about the last four, but
Yeah, I don't have the later ones. I think mine start out with I've got the real early one, the 26 to 38. And then mine end about 1960, maybe, or 61, I think, somewhere in there. So I need to get the later ones
if
somehow.
anybody works on car radios or works on transistor radios, I've also got a good number of the Sam's transistor radio manuals. I think I've got those through volume 1 through 79, and I think the auto radio I've got 1 through 49, and they're really nice too. They're very well drawn, and they're at the actual books. I don't have them electronically.
They actually, they put in a special series like this for
Yes.
auto radios.
Yes.
That's what I have. I have 1 through about 49 on that one, or 50. And
Okay.
then they made another one called TR Transistor Radio Series, and I have those up through, I think, volume 80. But yeah, those are really, really good.
Sam's did a pretty good job documenting them and giving you pictures and stuff so you can find components.
Yeah, they've got good alignment instructions on them too.
Yes.
But I've got the regular paper copies of the normal Sam's. Here's one here. This one, in fact, I just scanned this model up for a guy that wanted it. This is for a Sonora RCU 208. And so I've got all these, like I say, from number 1 through 750. And so if anybody wants a copy, get a hold of me and I can scan them up and email them to you.
Yeah, I gave you that one, Mike McCrow.
Yeah, that's right. Yeah, you gave me the one I didn't have, Larry, because like I say, mine ended at 750, and I think it was AM FM radio I needed. It was I needed like I was just missed it. It was like 753 or something or other. I really appreciate you doing that. Yeah, that was great. I'd like to get maybe a few more of those, but they're expensive to buy them on eBay. And
You can always go through what I've got left, Mike.
Huh?
You can always go through the ones I've got left. I might have some that are above 750, and you're welcome to them.
Okay, that'd be great. Thank you.
In the meantime, if you need more, Mike, I got them.
Okay, well, thanks, Larry. I appreciate it.
You were asking about the price of writer's manuals. According to my wife, the price would have been my marriage. So, it was way too expensive these days.
Anyway, one side note, just to Mike real quick. I talked to Fletcher and I talked him into just one of us, and maybe I need to talk to Pat, can pick that piece of equipment up for you up at Fletcher Anderson's.
Okay.
And on the 29th. Then we'll just bring it down to you.
Okay, thank you. I still don't know why, but
I didn't want him to ship it, so.
Oh, gosh, no. I'm just surprised he even knows who I am. So,
I think
or
important.
why I want it. But
He said he found out about you through the call letter.
oh yeah, because they did a special on me.
Yeah, that's what he told me. So he's
Okay.
a great guy. I think he's 94 or 5 or something like that. He's just
Who's a new guy?
he's in really good shape.
Oh, I had one other thing. Mike McCrow and I had a long discussion about vacuum tube voltmeters, and I wanted to present that to this meeting. Basically, I had stated in the past, and I want to correct it a little bit. I said I really feel like vacuum tube voltmeters are obsolete and not really useful anymore. But there is an exception to that. If you want a high impedance and an analog movement, that's where vacuum tube voltmeters can be useful. But there's something actually much better than a vacuum tube voltmeter. And if you ever run across one of these, I highly recommend getting it. it's the FET VOMs. It's the field effect transistor ones, and they're also high impedance, and they you don't have to deal with the vacuum tubes and all of that kind of related stuff. They're super nice.
Impedance, aren't they, Mike?
Yeah, they're 10 or 11 mega ohm.
Yeah.
So you get high impedance, and you get an analog meter. Because I use an analog meter reasonably often. I still like the analog movement, and if I need the high impedance, I'll go with this. This one's a Radio Shack one. It's a Micronta 2220, I think it is. Yeah, 220. And if you ever see one of these, hook one up. They're actually really awesome meters. It'll give you they look a lot like the Simpson or the triplet in size and scope, but it's great having that FET, which gives you the high impedance and still have the analog. And it's something you don't have to plug into the wall. You don't have to wait for it to warm up. It does have a on-off switch for the battery, because it does require, it's transistor based, so it requires a transistor or a battery to run it.
Does it have, Mike, does it have a zero adjust for voltage?
Yes.
It does.
Yeah, it's got 2 zeros. If you'll see there's a 0 ohms and a 0 meter adjust.
Okay, so, good. Then that would be good for FM alignment.
Yeah, because you can actually, that's kind of a cool thing about that. You can actually set the 0 anywhere if you wanted to.
Yeah, that's what you want, because when you're doing that alignment, it's gonna take that and it's gonna go below the center line and above, and then you want to get it right to 0 volts. So
yeah.
that's a good feature.
Yeah, so if you ever find that Micronta 22220 or any of the FET VOMs, in my opinion, and I'd love other people's opinion here, but in my opinion, they're better than a VTVM. They're smaller and just a really clean way to do things.
And you said that was a 22220?
Yeah, let me see.
You're too close, Mike. Back it up. You can't see it. Oh yeah, okay. All right.
It's kind of one of those things, if you ever see one, because they usually sell them pretty cheap. If you ever see one, boy, it's worth picking up. I like it because of that. What do other people use? Does everybody use VTVMs, or have you gone to the FET meters?
I've been using, I've got a Heathkit VTVM, and I've got a Simpson 260 on my bench, and then I have a Fluke DVDM on my DVOM, I mean, on my bench. Those are the 3 that I use primarily.
I use a Night Kit VTVM. It works really good.
Yeah, those are good too.
You just hook it onto the detector, AV or AGC line or AVC line, and start aligning.
Yes. Yeah, that's for sure.
On home run, that the entire Cleveland Guardians team combined. Home run hitters.
I picked up a Heathkit V4. It's one of their earlier VTVMs at a thrift store in North Plains the other day for $5, and and I took it home, and it still had the old Rayovac D-cell batteries in it, and then they had corroded. They weren't liquid, but they still had corrosion in it, and that had gotten down in that area. So I had to clean all of the connections. So long story short, I got all done with it and plugged it in and put new batteries in it and cleaned the connectors. And then I recapped it, and then I turned it on, and both voltage meters worked great. In fact, I was able to adjust the AC and the DC voltages on the pots there. and got those adjusted perfect, and it worked really good. But the ohm meter didn't work at all. And so Brian Toon had given me a service manual on it with a schematic and stuff. And so after that, after I was able to trace the circuitry down for the ohm meter, it was real simple, because right below where those batteries were sitting was the main resistor that fed that whole circuit for the coming out of the batteries for the ohm meter, and it was wide open. And it had that green stuff all over it from where those batteries had corroded out and leaked down onto that resistor and took it right out, I'm telling you. But I got a resistor that was an exact match for what the schematic called for, because I didn't want to have a variant there. You know, on the test equipment, you got to be real careful with installing resistors. And so I think it was 8.3 ohms, and I found a little carbon resistor that was exactly that, put it in there, and now the ohm meter works great on that thing. So I got a good working VTVM after all that. So
Good job.
but yeah, that's one thing I wanted to mention. If you're working on your test equipment, you don't want to, and especially with resistors, not so much capacitors, but you want to make sure that your resistors are exactly what the schematic calls for, because it's got to rely on that resistor to be correct before you can start testing anything else with it. So there's only kind of common sense there. Anyway, and then Mike, there was that discussion in there that Pat had in the email too about the auxiliary cable. And I just wondered, maybe if you wanted to talk about, maybe we can talk about that next week or something. It's getting kind of late tonight to bring that discussion up.
You saw my reply though, right?
Yeah, I did. I agree with that. The part about the AC/DC radios, I think, and that makes a big difference, because, you know, and the guy's right, or you would be right if you had, let's say, for instance, a hot chassis radio, and or even a floating B- radio, and you hook one of those up. If you did not make the changes in the radio with the polarized plug and rewiring the switch and all of that to make the radio safe. Now, if you have that thing hooked up, and especially if you put it to ground on a hot chassis, that's a complete no-no. But now you have a ground coming out on your 3mm jack that is possibly hot to AC, just like the chassis or the B- would be, so that could be real dangerous. But if you rewire the radio, like the way I explained in the last Tech Talk, then you're going to have 0 volts there at that point anyway. You'd be okay. But that potentially could be a real danger with one of those little 3mm jacks.
And the other problem is, I mean, things can go wrong. You could have a leaky bypass capacitor or something like that, and then all of a sudden you're injecting, high voltage DC into your unit. So having the caps there are really beneficial. Yeah,
I think putting the cap in line, and that's a really good idea. And and then just for safety's sake, it wouldn't hurt a darn thing, like you said, to run a bypass capacitor even on the ground circuit. But you could go ahead and where you take your two 1K ohm resistors and join the two stereo jacks to put a mono connection in on your wiper. You could put like a 0.02 or 0.01 cap right there, and then that's going to eliminate any kind of DC voltage at all, and then keep everything nice and clean that way. And it doesn't hurt the audio at all that comes in there. But I primarily only put those wires in on a radio that I've gone through and restored. And so I'll have all brand new wax paper. I mean, no, not wax paper. I mean, I have to say I replace all the wax paper caps in the radios with new ones and modern caps. But even still, it's not a bad idea to still do those safety measures to protect your equipment. And then like you said, you don't know, and normally speaking, if I do that for someone else, I'll tell them it's just, specifically for an MP3 player or a Bluetooth device, not to be confused with anything else. But, like you say, you never know what somebody's going to do. So that does make sense.
Yeah, I don't know if you have to do the switch that I mentioned, but
Yeah.
or not, either one. If you're getting some distortion, it might not hurt to pull that out. Then you don't have to worry about
Right.
going to find the non-station section.
Yeah. I'll mostly do it on transformer radios, though. I haven't done it myself on a lot of ACD. I have done some, and they seem to work fine. But like you say, if you don't have an RF switch, on the radio, then if you go to a quiet point, you can still get some interference. But normally speaking, if you have a good signal coming in, it's going to override almost any of that. But it depends, and you can still having that RF coming in if you're just going to, or if you have the wherewithal just to what I've found, what works a lot of times is just disconnect the antenna.
Yeah.
And that seems to cut your RF clear down. And then if you're plugging in a good audio signal that's coming in either off an MP3 or something like that, then you're never going to hear it. So maybe the simple way is to switch. Just you could actually put an inline switch right on the antenna itself. Might be a good option there. Or like you said, there's always the option of switching it right at the RF coming into
I think right at the Viper would be the best because
Yeah, I do too.
you're cutting out all previous stages.
Yeah, or you could cut it right at not even the wiper, but you could cut it off on the potentiometer, then the volume control where the RF hooks in. You could switch it there.
Yeah, that'll be odd. That won't be RF though there, right? Because that's after the
No, probably not. That would be,
But the thing
let's
is,
see, that's right there at the detector. And
I mean, the bottom line is
coming right off the second IF and right into the diodes of the detector, I think, and depending on how the radio's wired up.
Yeah, I mean, the way I'd probably do it is I'd just open up the detector or the wiper on that potentiometer, set that to one side.
Oh, yeah.
To your center, and then choose which way you want to flip it. So
yeah,
so the
from the connection.
getting what used to be the radio.
Yeah, that's a good idea because that's a good connection. You're following that same connection, and you're just gonna open that circuit going up to the grid of the detector tube.
Right. Hey Blake, when you add auxiliary inputs, I don't know if you saw the thread that Pat started. Do you always decouple your external auxiliary to your radio?
Yes, and I decouple it with generally a 0.02 to a 0.05, and I use two of them. And the reason I do is that the right channel on your device doesn't really want to see the left channel. So we do the mixing on the back side. So the input, if I balance it, I generally use a pair of 10K resistors on each side, 50K from the grounded side, if you will, of the chassis, and they use a pair of 0.022s or 0.047s. And that not only decouples decouples it from the radio, keeping any stray voltages, because it doesn't take much stray voltage in a 3.7 volt device to have a problem. And then I also use a second cap on the right and the left channel so that I decouple the left channel and right channel on the phone or the device.
Do you decouple the ground also?
I can't hear you. Try that again.
Do you decouple the ground?
Not if it is a transformer set. What I have found on the AC/DC sets is some of them are happy and some of them are unhappy. A 0.01 I'd have to go back and look. I can't remember. I think it was a 0.1, not a 0.01, that I would decouple the ground with. But I only do it when it's necessary and it's noisy.
So I think that's right in line, Mike, with what I was mentioning too.
Yeah, and I apologize. I'm working on a radio and I walked over to the tube checker for a moment. I missed that little part of the conversation.
Oh, no problem. There's an email thread going out about improving the or coming up with instructions for adding auxiliary input.
Yeah. Well, just go to the internet. Everything is always right. I forget who told me that. Oh my goodness. Okay. That tube's ugly enough that even if it's good, I don't think I'm going to use it.
Blake, what is that red car behind you?
That is a 69 Datsun 2000.
I just see part of it and I'm thinking, wow.
Yeah, there's a few folks in here that have seen it. It's a fun car. It's not a trailer queen. We drive it all the time, but it's a pretty good looking car, I think. But
Datsun was the predecessor of Nissan, wasn't it?
Actually, no. Nissan is the parent company dating back into the early 30s. However, Datsun was the trade name that they used in the United States for quite some time. Interestingly, if you go to Pakistan or to India, the Datsun trade name is still in use there, but they look like little boxy econo cars. Nissan still markets under the Datsun label. This one's an interesting car in that it says Datsun all over the car, but if you open the hood, the original engine in it says Nissan, and the reason being is the 2000 started its life as a racing car, and they pinned up demand for it in the public. They finally introduced the 2000, and it still has the Nissan label or casting in the valve cover. So I've been disqualified at contests occasionally. They look at it and they go, "Oh, he put a Nissan motor in it." Oh well.
Well, it sure got a pretty hood.
Thank you.
The only downside with those cars are as you get older, they're really hard to get in and out of.
No, they're not.
Oh yeah. My wife has a 91 Dodge Stealth and I can't get in it. It sits about 6 inches off the ground, and when I do fall into it, I can't get out.
Yep. My dad, God rest his soul, he died about a year ago. When he was 88, he went out and bought a Saturn Sky Roadster. And I went to see it the first time and I thought, oh, he's got this bar over the top of it. I said, that's kind of cool. Is that how you judge when it's in the garage? And he looked at me and says, hell no. He says, that's how I get in and out of it. And he did. He had that bar set where it would clear the windshield, but he could get his teeth on. Yeah.
Well, that's cool.
Where there's a will, there's a way.
There's one of those, there's a handle that you can get, Jerry, that it fits into the latch, the door latch, where when the door is open, it kind of is a metal bar with a U where the door latches. Anyway, you stick it in there and it's a handle and you can use it to stand up and sit down. Anyway,
yeah.
it also, it's one of those devices where it's got the metal hammer on it so you can break your windshield or your windows if you're in an accident, and a razor blade so you cut the.
Somebody makes a Lazy Susan for them too. I had a friend with a bad back and you put this padded Lazy Susan in the driver's seat and you get in out of the car.
Right. You sit down and swing in and swing in.
Oh,
yeah.
That's cool.
I almost need a hook to shut the door. I get into a car and the door is wide open and I can't reach over to get a hold of the door to pull it shut.
Yeah, mine's the same way. Cliff had difficulty with that. He almost fell out of the car a couple of times trying to shut the
Maybe
door.
that's why you carry a cane that's got a good hook on it. That
Right. Pull the
pull a
door
door
shut.
shut.
Hey, Jerry, you know where the door handle is on this car?
Yeah.
It's on the bottom, just above the bottom lip of the door. There's a handle. It's not on the top. It's clear down at the bottom. So
Oh, wow.
Yeah.
it works. You don't have to reach out this way. You have to reach way down here and close it.
Oh, wow.
That's all right. I've got an 04 or 2004 Nissan Xterra, which is luckily it's high and I can get in and out.
Oh, that's nice. We almost bought an Xterra. We had the Xterra and what's the other SUV they had back in 04?
Rogue?
No, the Rogue's new. Anyway, they had two SUVs, the Xterra and they had the Pathfinder. That's it. And then
That's
when
right.
the Toyota 4Runner was the competing one. And we basically went looking for a used one. And it was like, first one comes up, we're buying it. And
Well-
our credit union had a deal and we went out and what they offered was a Mitsubishi Montero and a Toyota 4Runner. And it was an 01 and it was a year old. And I think we saved a bunch of money. It's still parked in my driveway. Got a couple
No,
100,000.
it's not. The 04, the reason I bought it, well, this is not radio, but it was the last year that they built the fuel pump in the right place. Most cars today, they have electric fuel pump that sits in the gas tank, and you got to put it up on a hoist and drop the tank to get the dang pump out when it fails. Okay, not like the old days when it was hooked to the engine block with 2 screws or 2 bolts. Anyway, Nissan up until 04, the Xterra, you can change one out in about 15 minutes. The back seat has Velcro that you pull it up and there's an inspection plate under there. You take out 4 screws and there's your pump.
Wow.
You take out 4 more screws, pull the pump out or disconnect the wire, pull the pump out, put another one in and reverse it and you're done.
Wow. That's pretty
Yeah.
cool. You know what I
You
like about-
get right into the gas tank that way.
You know what I liked about the Xterra? It had stadium seating in it. The back seat sat just slightly higher than the front seat. So it was
Mhm.
easier for you to look over the shoulder of the person in front of you and look out the front window. And I just thought that was so cool.
Well, I can tell you why they did it. It was an accident and then they marketed it that way. What happened, it was a Frontier pickup. And the Frontier pickup had the bed was higher than the cab floor.
Okay.
Okay, bed of the pickup, but they didn't want to change the frame or the design when they decided to go to an Xterra when they welded a back on it. So they had to raise the back higher to get the back seat there. Okay, it was sitting on what was the pickup bed. Okay, and anyway, that's how it got higher.
Okay. So it's not an engineering feat. It was a marketing trick.
Yeah. Because it was just a modification of the Frontier pickup.
I'll be darned.
Hey, everybody, I'm fading. I'm gonna go ahead and sign off. So,
Me too. I'm getting on a tangent.
yeah, I golfed,
9 o'clock already.
I
Mike,
golfed 18 holes today down at the coast, and so,
Yeah, you're
Uh,
getting a little red there.
yeah, well, I just turned the light on, that's why. But anyway,
Mike,
so, I will see everybody next week. Have a good week, everyone.
Mike.
Yeah,
I'll
Thank
be,
you, everybody, for inviting this Passara guy.
yeah.
I will send you this weekend's presentation and email tomorrow.
Oh, good. Oh, good. That'll be great. That'll be fun. Looking forward to it. All right. We'll see everyone. Take care. Bye-bye.
Bye,
And-
Mike.
Can you send that to me also? That way I'll be able to talk about it the following week.
Oh, all right. Yeah,
Thanks.
I'll send that along to you.
I'm not gonna be at the meeting. I want to make sure I stay home because of COVID, so.
Oh,
Okay.
yeah.
It's
yeah.
covering chapter 10 on the audio amplifier. So if you want the mating 25 pages, it's out of the Marcus and Levy second edition. I think it's 110 to 135.
Perfect. I have the book, so that's not a problem.
Well,
All
have
right. Thanks, everyone. Happy
Thank
probing.
you. Take care. Get well.
Thank you.
All right, I think Mr. Thomas and I are gonna hang it up and finish up this whatever it is radio we brought over.
Sounds good.
No schematic, just a rusty chassis and 5 tubes.
Oh, fun. Have a nice evening.
You do the same, Linda. Good seeing you again.
Yep. Bye-bye.